Hi student, welcome in chemistry classes. Now discuss about coordination compound. The topic is crystal field theory. In our previous video, discuss about VB theory. Some drawback of the VB theory. So based on this concept, the CFT theory is produced. Okay. So VB cannot explain magnetic property of the complex, color property of the complex, and also magnetic property vary with temperature. So these are the point cannot be explained VB theory. And then also those complex, high spin complex and low spin complex which cannot determine for VB theory. So this drawback is fulfilled for CFT theory. Okay, crystal field theory. So first this crystal field theory proposed by Hans Bethe. So 1929. After later, this theory is a property. This theory properties fulfill applied for D block element like 3D transition element also. Okay. So what are the salient feature of crystal field theory? So generally, crystal field theory means the electrostatic attraction between the central metal ion and ligand. That is called that is called CFT theory. That means bond formed between the central metal ion and ligand is a purely ionic bond. It's a purely ionic bond. That means when metal is present and the ligand is present, the metal ligand bond is called ionic. So crystal field theory say the metal ligand bond is called a ionic bond. So this ionic bond form is a force of attraction. That means electrostatic force of attraction between the metal and the ligand. So this is a bond form, first point. Then the central metal ion and the ligand is should be point charges. So very important. The ligand considered as point charges or ionic dipoles. You can say is a ionic dipoles. So the ligands considered to be the point charges, also ionic simple dipoles or point dipoles. Say what do you mean point charges? Is a point charges are nothing but negative ligands, and then simple dipole or point dipole is called a neutral ligands. It is a negative ligand and also neutral ligand. You know about for the negative ligand, fluorido, chlorido, iodido, and then etc. hydroxido OX, OH minus, and then O2 minus. The neutral ligand also amine, water, carbonyl, and pyridine, and then etc. So these are the second salient feature of the CFT. So more important point. The first point, the force of attraction between the ligand and the metal to form ionic bond. Point number 2, the ligand considered as point charges. Point charges are nothing but negative ligands and neutral ligands, also point dipoles. Example for the negative ligand and then neutral ligand. Here dipole means it is a, you know about for aqua H2O. This is also the neutral ligand. Okay, this neutral ligand also point dipoles. That means OH2 is a structure of water. Here delta plus also delta means it is a partial charges. So it is called point dipoles. It is also dipoles. So these dipoles of the negative charge is directly attached to the central metal atom. Is directly attached to the central metal atom. That is called ion dipole interaction. So negative end of the ligands approach the metal ion. So these are the two important points for salient feature of the crystal field theory. Next, to formation of the crystal bond formation. That means a total complex formation. So according to the crystal field theory, the complex formation, the following steps is involved. So first in gaseous state, okay, that means a free metal ion state. Okay, all the 5d orbital of the central metal atom or ion or degenerate. All 5 d orbitals for central metal atom or degenerate. So degenerate. So all 5 d orbitals. You know about for the d orbitals in 3D series. Degenerate means same energy. Same energy like that. So dxy equal to dyz equal dzx equal to dx square minus y square equal to dz square. These are all d orbitals for equal energy for the free metal ion state. Now ligand to form spherical field of the negative charge surrounded by the metal like that. Here for the metal is present, here the negative ligand, this is called ligand. It is a central metal atom, it is a ligand. So ligand to form spherical field around the central metal atom or ion. Now the energy is raised. So the degeneracy split into two level. That means the degeneracy level is a change. That means dxy equal to dyz equal to dzx. So dx square y square equal to dz square. So this degeneration level is a change. Okay, so it is a more important point. And then also, metal ion is a present. Now, say metal is present. So the bond direction is present also. Consider it is a octahedral complex. Here central metal atom, here also direction. Is also z direction minus z. It is also x. It is a minus x. It is a y. It is also minus y. It is a central metal atom. It is a ligand is a present. Now ligand or approach to the this axis. Ligand approach for this axis. It is x-axis. Ligand approach. So ligand approach. So when a ligand approach for this direction is called bond direction. It's called a bond direction. So here consider it is a octahedral complex. It is a ML6. It is a octahedral complex. The direction plus x minus x plus y minus y plus z minus z. It is a direction of the ligands. Okay, it is another important point. Now you know about the d orbital. Now we see about for the structure of the d orbitals. Z is also y. So this structure is called the d orbital. Dx square minus y square is also dz square. Now say, then also x y. So dxy yz dyz. dxz. So these are all the 5d orbital. So dxy, dyz, dzx, dx square minus y square, dz square. So all the d orbitals degenerate. That means same energy. All the d orbitals have same energy. You see, that is the octahedral complex. You see, this for the 6 ligand. It is a yellow ball, central metal, atom or ion. It is also ligand. So 4 ligand in a plane, or 1 ligand above the plane, another ligand is below the plane. It is a octahedral structure. It is a axis. It's a ligand approach to the central metal ion. It's called axis. It is called a bond axis. Okay, so it is a z direction. It is a z direction. It is a x direction. Yellow ball, this planar yellow ball, it is x direction. It is a y direction. Okay, now it is a octahedral shape. Now here the dx square y square orbitals for the along the axis. That means lobes. It is called lobes. Lobes along the axis. For these are the 2 orbitals. These are the 2 orbitals, dx square y square, dz square orbital. The lobes are along the axis. Okay, so that means lobes via through the axis is a d x, also dy. So it is along the axis. So dx square y square orbital. Also dz square orbital, for it is also definite shape. It is also along the z axis. Along the z axis. So you see, it is a z axis for the dz square orbital. So the ligand approach for the bond direction also present in the orbital lobes. So that means a central metal ion or atom in orbital lobes. Ligand also electron rich compound. Metal, it is always positive charge. Also orbitals is present in electron. So the electron repulsion takes place. Metal electrons and ligand electrons repulsion takes place. So highly repulsion, the energy is increased. So here dx square y square and dz square, this repulsion. So energy increase. So energy increase. So destability. So this dx square is destabilized. So destabilize. So greater energy you compare to the dxy, dyz, dzx, because these are the 3 orbital, the lobes in between the axis. Oops. In between the axes, that means xy. So between the axes, here there is no ligand direction. So because the ligand is directly approach to the central metal ion, so the repulsion is very low, because the lobes, that means metal electrons for the in between the axes, here xy, it is also in between the axes, it is also in between the axes, like that you consider. So here xy, the orbitals present for here, it is also present for the here. So there is no bond direction for the orbital. So that's why the dx square y square and the dz square is a greater extent you compare to the dxy and dyz and dzx. So dx square minus y square equal to dz square is a greater than dxy equal to dyz equal to dzx. It is also energy. So energy. Now in this time, the 5 set of this d orbital split into 2 set, that is called crystal field splitting. Now in this time, all these 5 d orbital split into 2 set. One is a 2 is a higher energy, 3 is a lower energy. So this is called crystal field splitting. Okay, it's okay. Now the next, so all this point is to complete the formation of the complex. Okay, but in last one point, that means the ligand of the negative charge and the positive charge of the central metal ion to approach, the energy is decreased. That time the bond is formed, the complex is completed. So total the complex is formed. Okay, so these are the salient feature of the crystal field theory. This is a more important. Okay, so thank you.